This is chapter 8.2, part 2, sampling distributions. We left off doing a simulation and we did 1,000 samples and found that when we do 1,000 samples, the mean of the samples equals the population mean. But the standard deviation seems to have an adjusted value, smaller. And that was because when we looked at the distribution, it was a lot closer than the original population. And this is what we were looking at here. Here's the population distribution. It's wider. Here is the population sample distributions closer together. And so in this case now, we're curious about the shape of the sampling distribution. And what we know is if a random variable x is normally distributed, the sampling distribution of the sample mean is normally distributed, which we kind of see in those pictures. It leads us to some important conclusions here that we want to fill in. The mean of the sample means, which we did like up here, the mean of the sample means, this notation, very important, is the mean of the sample means. I'm writing it again because the mean of the sample means, because I'm going to say that and it can get confusing. It is equal to the population mean. Mean of the sample means, which is equal to the population mean mu. And the standard deviation of the sample means, sampling distribution, is equal to, and if you notice, this value was not equal to the population one. Right here, it's not equal to it. It is actually equal to an adjusted value. It's equal to the standard deviation divided by the square root of n. It's an adjusted value. This value has a very special name. The standard deviation of the sampling distribution, which is this here, is called, I'm going to squeeze it in here, it's called the standard error. So I'm going to use that term, but it's just the standard deviation of the sample means, or the sampling distribution. That's what we got. That leads us to another important conclusion right here, which we see in the notes here. As the sample size of the samples increases, what happens to the standard deviation of the distribution? Or what happens to this again is the standard error. What happens to the standard error? The standard deviation of the distribution of the sample means decreases. And again, what we're talking about here, the standard deviation of the distribution, is called the standard error. So again, make sure you make a note of that. This is called the standard error. And so that's what we have there. And so it's important to know that these conclusions are correct. This is the population standard deviation, and then the sampling distribution of the standard deviation of the sampling distribution is going to be equal to the standard deviation divided by the square root of n. It's important results here that we have. And so using that right there, we'll end up solving these probability questions that we have down here. But as we're thinking about this and writing this down, it's important that two assumptions are satisfied with regard to sampling from a population. So in order for us to do these statistics, one, the sample must be a random sample, and two, the sample values must be independent. And the way we check that is that the sample size is less than 5% of the population. And so that's important. It becomes a little bit more important in the next section. But we have those assumptions that we need to make sure we check. Let's go ahead and do a problem here. Let's go ahead and do a problem. The IQ X of humans is approximately normally distributed with a mean of 100 and standard deviation of 15. So this first case right here, what I'm looking at here, this is what we call the population distribution, right? Mean of 100, standard deviation of 15. But what we're looking for in this problem is compute the probability that a simple random sample of size n equals 10 results in a sample mean greater than 110. And so what's happening here is I'm looking at a sampling distribution, and so it has the normal shape based off of what we set up here. Okay, the mean is 100, but we have to use an adjusted standard deviation right here. So you can see 15 divided by square root of 10, because the sample size is 10. That is our adjusted standard deviation for a sampling distribution. We end up with a sampling distribution. And so in this case, the standard error or the standard deviation of the sampling distribution is 4.743. And then now what's the probability that we have a mean value greater than 110? It's 0.017. Where do those numbers come from? This is what you would do. Let me close that out. What you would do is go to Stat, Calculators, Normal. And in there, we need to put in the numbers. Let me make sure I retrieve the numbers correctly. Mean is 100 and then 4.73. So the standard deviation or the adjusted 4.743. This is 100. And the probability that it's greater than 110, 0.017. That's where I got that value from right here. Mean 100, the adjusted standard deviation, that the mean value is greater than 110, and that's what we have right here, and that's where I get 0.017. So that's what we have. There's our first example using this adjusted standard deviation to calculate a probability problem. This is very similar. Make a note if you're actually following along. Very similar to chapter 7.2. We're doing the same thing. The only difference is we're using an adjusted standard deviation. That's part 2.